podcast. Oh.
All right, so let's continue.
Welcome back to podcast number 6.
All right, so evaluating definite integrals, second method. So now we'll make the substitution just like before. We'll integrate, but at the same time, we're going to substitute for the limits of integration. So we're going to plug in the old limits into the value we have for u. All right, and that will give us our new limits. Since we've rewritten x in terms of u, we'll rewrite the limits in terms of u as well. And then we'll evaluate the new definite integral. We will not substitute back for u because we've changed the limits. All right? We'll talk about how this uses the fundamental theorem of calculus in a later lesson. All right, so substituting for definite integrals. This time, we're not going to substitute back. All right, so this is almost a very, very similar problem, slightly different. U is going to be x squared plus 3. We'll take the derivative with respect to x, du dx equals 2x, and now we do match. So du equals 2x dx. All right, so du is going to replace the 2x dx. U replaces the x squared plus 3. We need to find the new limits of integration. All right, so we'll just plug in 0 and 1 for u. All right, so we have u, if u of 0, I don't know how to, any other way to write that better. We'll just call it u of 0 here, is going to equal 0 squared plus 3. Or actually, maybe we'll just call it f of, since technically, I guess it's the old function, sort of. I guess we can just call it f of 0. All right, so we're just plugging in to x squared plus 3 because that's the new u, right? The 0 and the 1. So that's going to be 3. And if we plug in the 1, 1 squared plus 3 is going to be 4. So our new limits are 3 and 4. Okay. So now we have the integral from 3 to 4. Right? So we have u to the 1/2 power du, right? Because the rest of this is, it's all u and du besides the exponent there. So now we integrate. We're going to add 1 and divide by the same thing. Right? So we have u to the 3/2 divided by 3/2, and that's going to be evaluated from 3 to 4. Of course, u dividing by 3/2 is the same as multiplying by 2/3. So 2/3 u to the 3/2 evaluated from 3 to 4. So that's going to give us, and I'm going to multiply by the 2/3 at the end. So I'm just going to do that. So 2/3, I've got 4 to the 3/2 power. It's easier for me to do this, to write the square root and then cube that. And then minus the square root of 3. That's not a very nice number at all, but it is what it is. The square root of 3, and that's going to be cubed. We'll leave it as the exact answer. All right, so it's going to give us 2/3. This will be 2 to the 3rd power, so that's going to be 8. Minus, well, we've got the square root of 3 cubed. So I've got 3 square roots of 3. 1 square root of 3, 1 3 can come out of that. Square root of 3. Right? Because I've got 3 square roots. So 2 of the square roots will cancel each other out, and that will be a 3. And then I'm left with that 1 square root of 3. So we'll just distribute and leave it as an exact answer. So this is going to be 16/3 minus, the 3's will cancel now, so 2 square roots of 3. Exact answer. There's no reason to change that to a decimal.
So when would be the appropriate time to change it to a decimal?
That was a real world problem if we need to use it for something, if we need to plug it in for something else, or if it's multiple choice and it was had it as a decimal. But I would just leave it as the exact answer.
Hold up. Is that 16 over 3 minus 2 square roots of 3? Or is that 3
Yeah.
square roots of 3? 'Cause it should be 3 square.
No, the 3 will cancel. I've distributed 2/3.
Oh, yeah, that makes sense. That's how math works. Yep. Okay.
And then would there be an f of x equals or anything like that?
No, it's a numerical answer. It's not a function, just a numerical answer.
You're a
I wasn't sure.
That's okay.
So you just plug in the 4 and the 3 for you
Mm-hmm.
instead of the.
12%. The end? 12 of them?
13, 14.
So I'll give like 12 of 4.
16, 17, 18, 19.
Right, there's the next one. All right, so here, same problem. Oh, I did method 2 on that one, didn't I?
Yes, that's method 2.
Whoops, I did method 2 on this one, sorry. I was going to do method 1. So this one happens to be method 2. I was in a swing of things. And where we're changing the limits of integration. Now let's do method number 1. Okay, so now we're not leaving as u. We're going to do method 1, and we're going to substitute back. And we should get the same answer. If not, we've made an error somewhere. All right, so u is still going to be x squared plus 3. du is still going to be, du dx is going to be 2x, and then we move the dx over. So du is 2x dx. So exact same, everything else is the same. So u to the 1/2 du, we integrate. It was 2/3 u to the 3/2. And now we got to substitute back. All right, so we're going to plug in the x squared plus 3. So we have 2/3 times x squared plus 3 to the 3/2 power. All right, and so now, and that's evaluated from 1 to 0. So that's going to be, and I'm going to wait and distribute the 2/3 at the end. So we have 2/3. So this would be 1 squared plus 3. And we would take the square root of that and cube it. And then minus, we'd have 0. 0 squared plus 3, square root of that, and cube it. And then we'll multiply it by 2/3. And you can see we're getting the same answer. But I kind of liked not substituting back into this one. I liked substituting back into that simple one we had. All right, so this one would be 1, this would be 4. So this would be the square root of 4 cubed minus the square root of 3 cubed. So yeah, so it's going to be 2/3. This is still going to be 8 minus, and this is going to be 3 square roots of 3. And so we're going to have the exact same answer as before. 16/3 minus 2 square roots of 3. So exact same answer.
Different work.
In different work, yeah.
I think
Although
I
the
like
last 3 steps are exactly the same.
Yeah.
That's what I did.
Sometimes it's a little easier to.
First method.
You mean the second, this method or the other method?
Yeah, this method.
Yeah, I like
This method?
one
Okay. So it's totally up to you. I don't require you to use either method. I just require you to learn both so you have the options.
Right.
Because it really doesn't make a difference. So advantage when we substitute for the limits, we don't have to substitute back to get the integral in term, and get the back. We don't have to substitute back to get the integral in terms of x. That's the one advantage. The definite u integral that we get is equivalent with the original definite x integral. So it doesn't make any difference. It's just 2 different ways to do the same thing. All right, so here we're going to evaluate the definite integral, and we'll substitute back. All right, so what is my u? Take the derivative here. So we have du dx equals -1. And then I don't have a -1 there, so it's going to be negative du equals dx. So negative du will replace the dx, and u will replace the square root of 4 minus x. So we're going to have, and I'm not going to put the limits in until we substitute back. So this is going to be the integral of, let's put the negative out there, negative integral of u to the 1/2 power du. Right, and so we integrate. We're going to add 1, divide by the same thing. So this is going to be negative
Where'd the x
2/3 u to the 3/2.
You have an x.
Oh, I have an x.
So what does that mean?
Uh-oh.
It's still x u.
Oh, we have an issue. Ooh. we have an issue with this one. We're going to have to
I'm a problem solver.
rewrite this one.
I'm gonna knock one of those down on accident.
And
Accident.
Oh my god! Just like, what?
I was just totally not paying attention. We have the x there. What's that? Yeah, we're going to have to rewrite this. So,
Add 4 to the 1. Oh no. Oh no. Oh no, no.
see, the other thing we could do, sometimes if you can't rewrite it, you can solve for x in terms of u's and replace it. And I almost think that's what we may have to do on this one. So let me let me just do that. If u is going to be 4 minus x dx, all right, so then, yeah, this will work out much better. So u is 4 minus x dx, and or excuse me, 4 minus x, no dx. Du will be negative dx. Negative du is going to be x. We still have the problem of dx. We still have that problem with that x there. I just totally spaced it and didn't even bother to notice the x. Kind of had in my mind it was going to be a nice simple one, but it's not. So we need to solve, if u is equal to 4 minus x, I need a way to rewrite the x's in terms of u's. Okay. So, because I have that extra x there. So if I do u minus 4, that equals negative x.
Right.
And then divide by negative 1. I think I did something like this on the podcast. So this would be negative u plus 4 is equal to x. Will that make it better or the same thing I could have done with the x's? All right, let's see if it looks any better. All right, so now we'd have the integral of negative u plus 4.
Negative integral, by the way.
Or yes, and the negative there. And then this one would be so that just replaces that x
And then
times u to the 1/2 power. That's a little
So the
nicer.
negative
That's
du
better. That'll
to
be
the
better.
negative
Du.
Or times negative.
Yeah. So now that's a little easier that we can definitely simplify. There's no problem. We're just gonna add. We're just multiplying by a variable. No problem. Because we got rid of that. Because the radical now only holds one term. So now we don't have a problem. So we have, it's a little sticky over here, but not so sticky over here. So now it'll work out fine. So now we have negative u to the 3/2 power plus 4u to the 1/2 power du. That everyone agrees we can do, right?
Yeah.
Now we're okay. We can integrate. So sometimes you have to do a little creative substitution here. When you've got one too many x's, it'll work in a problem like this, where you've got a radical. That's usually where it turns up, with a radical, and I've got a binomial in the radical. We can just do a little creative substitution here to solve and replace for x. This is about the only time I can do this. It also helps when you've got a binomial in a denominator to make it be a single term.
To solve and what?
So creative substitution to solve and replace for x.
You
Got one extra x there.
Solve.
All right, so now we're fine. We'll just integrate each of these, and I'll distribute the negative at the end. So this is going to be, now it's going to be,
Oh yeah, you're missing a
You're missing
2/3.
2/3 in front of u when you get the integral of u. to the
I missed a 2/3.
U to the 1/2.
Yeah, u to the 1/2 is 2/3 u to the 3/2.
So 2/2 plus 1/2 is 3/2. And this would be to the 1/2.
Oh, you're not. Okay, never
Oh, I
mind.
thought you were doing the integral.
No, I haven't integrated yet.
Oh, okay.
All right, so this is going to be u to the 5/2. So is everyone okay if I just do times 2/5 instead of divided by 5/2 and change it? Okay, so 2/5 u to the 5/2 plus, so this would increase by 1. We'd have 2/3 times 4 u to the 3/2.
Mm.
And we're using method 1, so we will substitute back again and end our parentheses. Everyone okay so far?
Yeah.
We'll just simplify it now. We have negative 2/5 u to the 5/2, and then plus 8/3 u to the 3/2. And now we got to substitute back, which was the 4 minus x. So we have negative 2 fifths 4 minus x. I'm just going to rewrite that as a square root, all raised to the 5th power. And then plus, oh, might as well make that a minus. May as well distribute the negative. Minus 8 thirds. So this is square root of 4 minus x cubed. And now we're evaluating that from -5 to 0. At least it'll be a nice, it'll be a square root. All right, so we have negative 2 fifths. And so it's going to take me a little, I'm going to actually extend the page because it's going to take me a little space to plug all these things in. Because I got to plug in both of them, and I got 2 things here. What's that?
At the top of that.
Oh, I dropped the negative right here. So this is negative, this is positive right here. Thank you, that's positive.
You're positive.
All right, so now we're going to plug in both of those. This thing is a 0, and it looks like a 6. All right, so we have, I'm just going to start going over here. So 2 fifths square root 4 minus 0 to the 5th power minus 8 thirds square root 4 minus 0. Right. And to the 3rd power. I'm going to use parentheses because I got to subtract everything now, but with -5 plugged in. So 2 fifths square root 4 minus x, or excuse me, 4 plus 5, right, because that's minus a negative. 4 plus 5 to the 5th power. And then minus 8 thirds, 4 plus 5 cubed. And we got everything, right? Yeah. So this is going to be 4. Square root of 4 is 2. 2 to the 5th power is 32. So this is 2 fifths times 32 minus 8 thirds. So this is going to be, that's a cube. So this is going to be 2 cubed, so that'll be 8. And then I'm going to still leave these parentheses here because I'm subtracting all of this. So we have 2 fifths. So that's 9 to the 5th power. Or square root, excuse me, square root of 9 to the 5th power, which is 3. 3 to the 5th power would be 243. And then minus 8 thirds. Square root of 9 cubed, so that would be 27. 3 cubed, 27. All right, so now we'll just simplify this. So now we have 64 fifths minus 64 thirds. This is going to be a minus. I'm just going to get everything and say, I'll just kind of group the fifths together and the thirds together. I'm hoping something will cancel out. So that's going to be 486 fifths. And this is going to be a plus. This will reduce. So it's going to be a plus of 72, because that's going to be a 9. 486, right? Because that would be 243 times 2. All right, so let's see. We got 64. So 64 minus 486 is going to give us a negative 422 fifths. And then we've got a negative 64 thirds and a positive 72. And we're going to have to change them all to 15ths. So 422 times 3. Oh, you got them?
What's the final? If you want the final.
Oh, okay. Well, for the I may as well just change them to 15ths, and then I'll put the final answer down. So this is going to be times 3. It would be negative 1266 fifths minus, and that would be 64 times 5, 320?
Don't you mean over 50?
Oh, 15, yeah, I do. And then plus, I don't know what 72 times 15 is.
72 times 15.
Yeah.
1,080.
1,080. And what was your final answer?
Negative 506 over 15.
Negative 506 over 15. So what is that telling us?
Calculator. Stupid.
Ooh,
Sorry.
I want to do a closing.
Oh, we don't have time.
So I'm going to close the podcast. We always have time.
No, I can close the podcast.